In this video, we'll learn what the trigonometric ratios sine, cosine, and tangent are. Now, to begin with, we start with a right-angled triangle. So remember, a right-angled triangle is a triangle, of course, in which one of the angles is a right angle. And we indicate that it's a right angle by adding a little square in the corner there. Remember, a right angle is an angle which is equal to 90 degrees. Now, any right-angled triangle has one of its side lengths which is known as the hypotenuse. And the hypotenuse is always the side length which is directly opposite the right angle. And it is also the longest side of the triangle. That's the hypotenuse. Now in trigonometry, what we'll be interested in is the sine, the cosine, and the tangent of any one of the interior angles which isn't the right angle. Now that's quite a long sentence. Let me illustrate this with a diagram. Let's consider again a right angle triangle. So we have our 90-degree angle here. And let's say I'm interested in this angle, which I'll label A here. Now, relative to that angle, there are two side lengths that we'll need to point out. There's one side length which is directly opposite the angle A, and we can see that it's opposite here. And that side length is known as the, quite simply, opposite. And I'll just write that OPP for opposite. The other side length that's going to be of interest is this one here, which is right next to A. And therefore we call it the adjacent side length. Remember, adjacent means next to. So we'll label that adjacent. And of course, just as for any right angle triangle, we always have the hypotenuse, which is, remember, directly opposite the right angle. Now, relative to that angle A, we define three trigonometric ratios. And it sounds much more complicated than it is. A lot of mathematicians in history were notoriously arrogant, and we like using these tricky words. Trigonometry basically means the study of triangles. And so all that we're looking into are the ratios of the different lengths of this triangle. What I mean by this is, again, I'm insisting here, relative to the angle A, we define, let's get started, the sine of A, which we write sin of A, and that's equal to the opposite side length, which we have here in blue, divided by the hypotenuse, which we have here in red. We also define another one, which is known as the cosine of the angle A, and we write that as cos, C-O-S, of A. And that is equal to the adjacent divided by the hypotenuse. So that's equal to adjacent divided by the hypotenuse. And last but not least, we define the tangent of the angle A as being equal to the opposite side length, the side length which is opposite the angle A, divided by the side length which is adjacent to angle A. So that's tan of A is equal to opposite divided by adjacent. Now, let's look at a quick example with some actual numbers here. Let's say we're given this right angle triangle here. and we're interested in this angle A. And for argument's sake, let's say the opposite side length, the side opposite A rather, is 3. The side length adjacent to A is 4. And the hypotenuse is 5. Now in this case, using the trigonometric ratios we just saw, I'll just scroll up for a second. If needs be, you can jot those down very quickly. Using the trigonometric ratios we just saw, we could say that sine of A, which is equal to the opposite divided by the hypotenuse, would be equal to 3 over 5, which is equal to 0.6. In a similar way, cosine of A is equal to the adjacent of A divided by the hypotenuse. The adjacent of A is the side length next to the angle A, so in this case 4, divided by the hypotenuse, which is 5. So that's 4 divided by 5, which is equal to 0.8. Last but not least, we saw that we would have the tangent tan of A, which, remember, is equal to the opposite of A divided by the adjacent of A. So in this case, 3 divided by 4. So we write that. Tan of A is equal to 3 over 4, which would be equal to 0.75. And there you go. We've just calculated our first trigonometric ratios, sine A, cosine of A, and tan of A. One thing we notice here is that all of these ratios are less than 1. And in fact, that's always going to be the case for sine and cosine, not for tan. But sine of any angle, so sine of A, will in fact always be less than or equal to 1, and greater than or equal to -1. If ever in your calculations you find that a sine is bigger than 1 or less than -1, then something's gone wrong, and you need to check your calculations. In the same way, cosine of A is also always less than or equal to 1 and greater than or equal to -1. And if ever you find that your sine or cosine doesn't fall in those values, then something's gone wrong. Important to notice, though, or rather important to note, tan of A can take on any value. So, for example, if you found tan of A is equal to 5, don't panic. That could be perfectly fine. There's nothing wrong with that. But these two facts that I've just highlighted here are very important. So, just to remind ourselves, we saw that the sine of an angle A is equal to the opposite divided by the hypotenuse. The cosine of an angle A is equal to the adjacent to A divided by the hypotenuse. And we saw that the tangent of an angle A is equal to the opposite to A divided by the adjacent to A. And to make things a little simpler, we're just going to write opposite as capital O and hypotenuse as capital H. Similarly, for cosine of A, we'll write adjacent as capital A, and again hypotenuse as capital H. And finally, for tangent of A, we'll write opposite as capital O divided by adjacent capital A. It just makes things a little easier. Now, we'll finish this with one last point. In all of these trigonometric ratios, I've always been referring to this angle A. And using the notation we just saw there, relative to this angle A, the opposite side length would be O here. Its adjacent side length would be A, which is right here. And of course, it's the hypotenuse of this triangle is opposite the right angle, is capital H. But now, if we were to consider a different interior angle, or the other interior angle, I should say, let's say I'm looking at this one, B, then things would change slightly. Relative to this angle B, the opposite is this side length, and the adjacent is this side length. And of course the hypotenuse is still the hypotenuse. It's always a side length opposite the right angle. So just keep that in mind. The opposite side length and the adjacent side length are relative to the angle that we're considering. So, for example, again, if I take the same triangle as we had earlier on, we had a right angle triangle 3, 4, and 5, and if we were to consider this angle B, then in this case, sine of B would be equal to opposite over hypotenuse, and in this case, the opposite to B is 4. And the hypotenuse is 5, so that would be equal to 4 over 5, which is equal to 0.8. The cosine of B would be equal to the adjacent of B, so in this case 3 divided by the hypotenuse of the triangle, which is 5. So that's adjacent divided by hypotenuse, which is 3 over 5, which is equal to 0.6. And finally, the tangent of B is equal to the opposite of B divided by the adjacent of B. So that would be opposite over adjacent, which is equal to 4 over 3, which I won't write as a decimal, but it's approximately equal to 1.33, etc., recurring. There you go. So just keep in mind that the sine, cosine, and tangent, you need to remember that the sine is equal to the opposite divided by the hypotenuse. The cosine of an angle B or A is equal to adjacent divided by hypotenuse. And finally, the tangent is equal to the opposite divided by the adjacent. You also need to remember that the terms sine, cosine, and tangent are relative to the angle that we are considering. That's very important. Now, in the next video, we'll be learning a method to memorize these different formulae, and the method we'll be learning is known as SO, Ka, Toa. So, hope that you'll be watching the next video, and there you go. Hope it helped.